Good morning, everyone. Welcome to week 7. I hope you've had a good flex week. I'm sure many of you are tired, no doubt. A lot of you got iteration 1 in on Monday. It's crazy to think that's 48 hours ago. It feels like just a moment ago to me. I do hope you've kind of like had a moment to breathe since then. I hope that also you are doing the peer review as well, because the peer review is an important part of this iteration, and it helps your tutor figure some things out. So we've tried to make it a little bit easier with the Google form, but we'll see how we go on that front. In terms of where we're at now, besides iteration 2 being due and the peer review, we're pretty much just on the final run of COMP1531 now, which is doing iteration 3. It was released to your project the other night. And in terms of the experience that you all have with this, typically what we find is that iteration 1 is not a lot of work, but some students find it kind of, I guess, challenging anyway, because it's like all the new stuff. Iteration 2 is really the hump where things kind of feel the most painful, and that's because the volume of work's increased and people are still figuring out a lot, and there's new concepts and a bigger expansion. Iteration 3 though tends to kind of be back on the easier side, I guess, where there is still a lot of work, but it's all Flask, it's all the same kind of stuff. There's not really any massive new programming concepts. There's a couple of tiny things. It's just kind of like it's the manageable iteration. So for those of you who are feeling stressed, it should be very okay, particularly those who just make an effort to try and get organized this week. So that's super exciting. Tomorrow at the end of the lecture, we will talk about iteration 3. Iteration 3 was deployed to your repo, I believe, on Monday night, Tuesday morning. If it's not on your repo yet, I would suggest checking your merge requests, and if it's still not there, maybe post on the forum, maybe post publicly so other people can post, because I've definitely talked to a number of students that that have it. So it's probably floating in a merge request, etc. So in terms of the marks, in terms of auto marks and whatnot with iteration 2, the auto marks were relatively high. It's hard to tell because we don't really care how high the auto marks are. It depends how that balances against the manual marks. But yeah, the marks are relatively high, and that's somewhat expected from from a group work course. And the question about, does that mean the exam will be harder? I mean, we have a sense of how hard the exam should be at the start of the term. We don't really pull levers too hard, etc. So that's all well and good. I think that's all the admin. My internet's better now, so hopefully we don't have any slowness. Hopefully that has an improvement. Let's get on to today's stuff. So the cool thing about week 7 is that for the first half of this week, today, it's all waffle stuff. We're not doing any programming today, which is kind of cool comparatively, because I know definitely some people just kind of get a bit tired with these things naturally, because it's all this programming, etc. So today's just kind of going to be talking a bit more about engineering, and the topics today, which are requirements as an overview, and then looking at requirements in terms of how to describe them in a bit more of a human way. These are really exciting topics as far as I'm concerned. Funnily enough, not specifically today's lecture, but this particular topic broadly is what actually got me interested in teaching this course, because when we think about software engineering, and let me get into the lecture deck here so we can really get stuck into it. When we think about software engineering, or when I deal with software engineers, the importance of requirements and understanding a system are grossly understated. It's just something that a lot of students or even people in industry sometimes aren't going to get their head around, because when people think of programming, they think, oh, it's writing code, and then as they get better, they think, I have to test that code and I have to design that code well. That's how I'd see a lot of students' kind of brains work. However, I think there's a very strong argument to say that the most important part of building a system is figuring out what you need to do. It's actually understanding the problem, and this this again can be applied to such a wide array of parts of your professional life. So it's good to get into. And we're going to be talking about requirements broadly, how to find them and how to collate them. And, before we get into this, it's like someone's like, what are requirements? They are, there'll be a formal definition on the next slide anyway, but that is the specification that tells you what to do. When you do the project, we've written the requirements for you. We say, here's the interface, here's the rules. Here's the rules that if you follow, you will succeed. But in kind of reality, when you're managing your own projects or your own activities, you often have to actually define your own rules because someone's come to you with a problem, right? My sister, my sister the other day, this is very random, but she messaged me and she was like, I want to build how much does an app cost? And I was like, I don't know. What do you want to build? She was like, I want to build like a social network for COVID or so. I didn't ask any questions because I was like, I don't know. I'd still have to get back to her. But, the worst thing people can do is be like, I got a code. Oh, how does this work? Let's do this. Should this be on Android or iOS? She's like, what should we write it in? The first question is like, what are you actually doing? What are you trying to solve? And that's where requirements comes in. It's the step before you even think about a solution. So obviously it fits into the first part of this. This diagram comes up every second week. It's the yellow part that happens before the blue part. So again, most people start off programming doing the green. Courses like 1531 make you think a little bit about purple and blue. And we're really talking about a lot of yellow today. So the IEEE, one of those, international standardized bodies, defines requirements as a condition or capability needed by a user to solve a problem or to achieve an objective. So what I like about this simple definition is it's essentially saying that a requirement is a description of what is needed to achieve an objective. If you can't, it's how you define success fundamentally. Because if you can't define success, you can't achieve success. Otherwise, you're just floundering. So we can think about this more broadly, though, as like it's an agreement of work to be completed by all the stakeholders in a project. So who are stakeholders? They are people who are invested in the success of something. So when UNSW, goes and says, oh, we're going to go from semesters to trimesters, the stakeholders are everyone from students to staff, to researchers, to building managers, to security, to UNSW, like literally everyone in that case. It's an agreement and understanding of all the work to be completed. And you see this all the time, right? Like it's planning, but like planning before you actually say, we're going to use this type of material when you're building a building. It's actually like, where are we going to put the second airport in Sydney? What is it going to have to do? How many planes is it going to have to come in every day? How big is it? Which way are the flight paths going to go? It's like, if we do these things, then we have succeeded at what we're trying to do. So agreement of work to be completed by the stakeholders and essentially a bunch of descriptions and constraints of a proposed system, right? So I just gave that airport example then. Well, descriptions and constraints could be, okay, well, we need to build this system, but it needs to do this much, or it can't do this. It's really, again, as I said, it's the rules around it. There's a quote here which I really like. The hardest part of building a software system is deciding what to build. No part of the work so cripples the resulting systems if done wrong. And this is why I think this topic is the most interesting to me, because it's the most impactful one when you get it wrong. If you try and describe what defines success and what constraints you're working to, if you describe those things incorrectly, you have a world of pain, because everything you do after that doesn't work well, and this kind of comes back to that lecture, if you remember back in week 3, where we talked about verification and validation, and we talked about verification as that a system is built right, and validation, which is starting to get into this area, is that a system is that the right system was built. So if you remember that definition from the earlier lecture, it's like, this is all about figuring out what the right system is. Because validation, which we kind of talk about as part of this, validation is looking at the system you built, looking at the system that we said we need to build to be successful, and seeing if it matches that. So that's what requirements are in a nutshell. Now, a very kind of this concept isn't that dear to my heart, though it's fairly kind of important in the scheme of the education on this topic, because you'll see it come up in a whole bunch of places. But when you're defining requirements, and if you think about requirements, think of them as just like a to-do list of items. So, for instance, if we said we're going to design COMP1531, but before we even design COMP1531, we start writing a list of requirements about what that system should be. And maybe the first requirement would be that we need to teach the basics of testing, or the basics of testing shall be taught. Or another point might be like, what is the other kind of key things we do in this course, right? The fundamentals of HTTP and a web server shall be taught as well. So this is kind of how you would write requirements in a way, right? There's no structure to this specifically. It's just you're defining success. If the fundamentals of HTTP and web were taught, you've succeeded. You have designed and implemented the course correctly. But when it comes to writing out these requirements, we can categorize them into this functional and non-functional bucket, where functional requirements specify like a capability or service that a system should provide. It says what the system does, and non-functional requirements tend to place a constraint on the system and say how the system should achieve that. So if you think about, I think this is a very confusing topic personally, and even looking at it for years, I still get tripped up on it. We've also put a link here which kind of elaborates on this a little bit. I would recommend you read this. It's a very short page, but they give some kind of examples of the differences between them, examples of functional requirements and non-functional. You can see here the functional ones, saying the sales system should allow users to update customer records, and the software system should be integrated with the banking API. Functional tells the what, or what capabilities it has. Non-functional tells the how or the constraints. So you can see here, every unsuccessful attempt by a user to access an item of data shall be recorded. So the reason I think functional and non-functional requirements are kind of hard is because I don't think there's like a really, really clear-cut distinction between them. And I see this all the time with students, right? Where a student looks at this and says, oh, this is telling me what it does because it records it. Okay, if a user accesses something, we're recording it. That's a capability. That's what we're doing. And I think that's kind of one of the harder parts here, because I think it's very easy to spot a non-functional requirement because it just looks like that. It's like employees should never be allowed to update their salary information. That sounds like a constraint, doesn't it? That sounds like a how to go about the what, So it's easy, I think, to look at that and say, oh, that's a non-functional requirement. Functional requirements, I think, are a little harder, because I think ones like something like this could be mistaken as that. But the best way, I think, to think about it is that, functional requirements should be giving you something, and non-functional requirements are kind of taking that away a lot of the time. So when you look at something like this, I think this one is very borderline. If you just gave this to me in a vacuum, I don't even know what I would say to it, to be honest. But in this case, it's kind of like, it's trying to constrain the system, right? It's trying to limit it, take control of it, etc. So that I can understand why it's written here as a non-functional requirement. Blake says a functional requirement is usually the ones that the end user would see directly. I don't know if that's the case. Sort of. Like, if a functional requirement is something you can do, if it's a capability, then the user's probably going to interact with that in some way. But they'll also kind of feel a non-functional requirement. Like an example of a non-functional requirement that I think we have further down here on the slides, right, is that if you're building a system, a functional requirement might be that the system needs to send a notification to all users whenever there's a new post. Think about this like your UNSW Streams app, or someone comments on an existing post. So you're describing a capability, notifications when there's something to be notified of. And then a non-functional requirement says that, the system must send emails no later than 30 minutes after from such an activity. And it's like, in this case here, you're kind of putting a constraint on it. You're saying, yeah, this is what I want you to do, but here's a how, here's a specific way. you're narrowing the scope a little bit. So this one I think is much clearer. And when we ask you questions about this on the exam or something else, we tend to ask questions that we don't think are super ambiguous either. You know, like I would expect all of you to be able to tell if we gave you both of these and we said, well, if we gave you both of these and we said which one's functional and non-functional, by the end of this course and everything else, we'd expect you to be able to tell that one pretty easily. Some of them are hard though, so when you are reading up on this, and I would recommend Googling around too, because there's lots of different websites that explain it different ways, and some suit different people's style of understanding better. You're always going to see about 10% of them that you're like, I don't. Okay, so don't stress about that though. But yeah, that's the gist of it. They're just kind of different ways of categorizing requirements, because then you can say over here, this is what we need to do, and these are some constraints on it. But yeah, interesting stuff. Obviously, you could subcategorize those further, but these are two very kind of common terms you might see out in the world. You might see people be like, do we have a list of our functional requirements? And you're like, oh, I remember that. That's the what we do. Sure. Okay, let's think about all the capabilities that we need to provide. So that's it on functional versus non-functional. In terms of actually like figuring out requirements, because I think it's okay to define a requirement, which is hard anyway because it varies so much. But a big part of this lecture is about figuring them out yourself. Because again, being given requirements is somewhat easy, and the example I would give you, and I give this example most terms, is that it was something I was exposed to with SunSwift, but in 2015, we tried to get a car legal on the roads, like a solar car, like legally allowed to drive on the roads, like permanently kind of thing. And what was very different about that experience for us was that previously when you're kind of doing these projects, you're like often, there might be some rules you have, so various projects, there's always some kind of rules. But the rules with this were extensive, and you could say that this was a set of requirements dictated by the Australian government about what determines whether a car is roadworthy, right? So you think about what requirements are, and you think, well, it is a definition of success. So they're like, here's a bunch of rules, here's a bunch of descriptions of a system, that if you comply with that, you have succeeded at meeting our goal, which is a certain standard of vehicle, right? And I can never navigate these websites, but I was just wanting to show you an example of, so these are actual real things. These are all the different rules in Australia about what cars need to do. You can think about this as a giant bucket of requirements. So for instance, which ones look interesting to you? Indicators, brake hydraulics, windscreens, steering mechanics, sun visors. There's literally look at this, rules on sun visors. Those things that you like flip down in your car when the sun's in front of you? So there are whole buckets of requirements on this stuff that you can go and look at. And I like this example because they're not telling you how to design a car. They're not saying, it needs to have... they're saying every car that you've seen in Australia complies. 99.99% of cars you see comply with this. They're all different design. They're all different, made up differently. They all go through different amounts of testing, but they all comply with the same set of requirements. And there'll be a whole bunch of random stuff here, like, where's an easy one to read? This one's a very, very short one, but sorry, let me just... Specific requirements. Okay. The sun visor shall be constructed of or covered with energy absorption materials nominally over the whole area such that the requirements of falling asleep. So basically they're saying if you have a sun visor, it needs to be of some material that can absorb energy. And then they're like, read this one to see more. When tested with this, the test sample shall arrest a moving head, so it'll stop your moving head in such a way that the deceleration does not exceed 80 times the acceleration due to gravity, except during a period of less than 3 milliseconds. Oh, like what does that even mean, right? So like I find these examples interesting because this is a very extreme example of requirements. This is kind of getting into the massive regulatory area that you'd imagine big companies like space companies and aviation companies and everything else have to comply to. But this is the Australian government setting a ton of requirements. Now, the reason this is a difficult topic is because there really is no tactile understanding of requirements, I think, because it is so broad. For instance, you could argue that these are requirements put down by the Australian government on car manufacturers, right? But within a car manufacturing company, you know, because if you imagine you've got your like Oz government over here and they have a bunch of requirements that are called the ADRs for cars. Then over here you have your company like Toyota. And Toyota are going to go through, you know, a design phase where they sketch things up and they plan it. They'll go through like a building phase, some kind of quality assurance, which, you know, you could call testing, etc. And, you know, that's trying to generalize this a bit too much maybe with software. But what you'll also find is like Toyota or any car company don't just like take these rules per se and then go and design a car. They might have their own set of requirements that they need to work with. You know, for instance, Toyota cars might all need to have the same kind of electrical equipment so that they're all kind of compatible and technicians can work with them. So requirements aren't just like a thing that's like you do requirements and so does whatever. It's actually kind of like, well, the government has a set of rules that define success. And then you come over here and like, you know, your organization might have more rules that define success or potentially add more capabilities or put more constraints on it as well. You know, some manufacturers would consider some of the rules in here too generous, you know, and they put even more on there. You know, like all those really safe cars you see would look at some of these and think, great, but that's like way too unsafe. You know, I don't know what airbags, is there airbags here? I don't know what the rules around airbags are, but it's like some people would take it even further, right? So don't think of this like that static a thing. It's like, yeah, sometimes these two things might be combined together. Whatever it is, whoever's doing it, however many people are doing it, however much comes out, all we're dealing with when we talk about requirements in the context of engineering is coming up with a set of rules that define success for people to design, implement, and test to. You know, because all of this stuff here kind of comes back and gets benchmarked up here. It all gets validated, checking if the right system was built back to the requirements. So that's what, you know, that's what requirements are. We didn't manage to get the car road legal in the end. We ran out of money. We got very close though. It was very, very challenging. The main hurdle we had, I think, was, I can't remember what the main hurdle we had. It was like 6 years ago now. 6.5 years ago now. It's a long time. So this is all well and good when you get given a document. But the real question is then, how do you actually define requirements yourself? Right? This one is really hard. And I want to come up with an example with all of you that we can explore. You know, a problem space that we can explore together. And, you know, this is the kind of stuff I do every day. I was doing this kind of thing last night. Maybe not as structured as this, but, you know, there's like a broad thing we need to solve. Think about trimesters again. UNSW wants to go from semesters to trimesters. UNSW wants to go to online teaching. All of these things, you know, someone starts and says, here's an idea. Here's a very broad problem or opportunity space that we need to explore. Let's actually figure out the rules that define success. So to get our requirements, we want to go through a process of requirements engineering. And this process, you could broadly say, is made up of 4 parts, which is elicitation, analysis, specification, and validation. Now we're going to run through what these 4 parts are in a sec, but let's just first talk about requirements engineering as a whole. Requirements engineering is a set of activities that is focused on identifying the purpose and goal of a software system. That makes sense. Requirements engineering, you could say, is a set of activities to determine requirements. And what do we know requirements are? Well, they describe the purpose and goal of a software system. You know, we've talked about this a few different ways. I'm more interested, because I mean, that was kind of obvious, right? Like, we need a process to come up with requirements. So that one makes sense. The second one, though, is more interesting. A negotiation process where stakeholders agree on what they want. And this is a really important part of this idea of requirements engineering or coming up with requirements, is that it is arguably one of the most soft touch human parts of the whole process. I know we just pulled up this kind of giant, scary, legalistic looking document before, but that would have come out of a whole bunch of stuff. Like, you think about these rules, the Australian government doesn't just come up with rules, right? they talk to industry all the time. You know, they have advisory boards. They figure all this stuff out. It's the same with the uni. Whenever the uni makes decisions about programs, they have boards of academics. They have boards of industry. They have boards of alumni. They do all this thing. And it's a big negotiation process to figure out what is the purpose and the goal of the system that we're trying to build. So the reason I point this out is because it's very human, and that kind of ironically makes it the most important. And the reason I think this entire topic is so interesting is because I think when students when you start doing software, when you start, 1511 or whatever, and you think, wow, I can write C code. What ends up happening is that I think it's easy to overlook the fact that your ability to program doesn't really mean much. It really doesn't. And if I go back to this thing here for a second, I mentioned that you start off in the green category, writing code. Then you might test a bit of code and design a bit of code. What are you competing against, right? What are you actually competing against out in the real world? Are you dealing with, you're trying to get other programmers and beat them and get better jobs than them or everything else, right? You're all competing for the same spots at Google or something else. You need a way to stand out, fundamentally. And being a good programmer is rarely going to be like that for most of you, because realistically, there's a great bunch of online courses out there that teach you how to program, bunch of boot camps. There's a whole bunch of very cheap labor out of Southeast Asia and other parts of the world that are as good at programmers as you, right? Just because you've been to university doesn't mean that there aren't people out there that you can pay $10, $15 an hour to actually produce good code. What's going to make you stand out is your ability to understand the blue and the purple, and in particular the yellow. In any kind of job you get, particularly in a country where you're speaking your native language, because of how big a deal communication is, because anyone can write code. Not anyone. Tons of people can write code. Tons of people that are going to work for cheaper than you are going to write code, right? Where you can be different is that you can write better code that's better designed, and you can write more robust code that tends to be better tested. That's a good level up, generally. The next level up is to be someone who can actually communicate, consolidate, and negotiate. And that's where most people get paid a bunch of money. I mean, you look at big companies, team leaders, group leaders, all this kind of stuff, like engineers like you that move through the ranks. The further up they go, a lot of the time they're not spending time writing code because they know anyone can write code in that world. They're spending time actually figuring out how to design systems, or even more than that, figure out what problems you're trying to solve. And that's what the best engineers do. The best engineers are not writing code, they're figuring out systems. And I mean, I was in a call last week with a UNSW alumni from 20 years ago who runs their own cybersecurity firm, right? It was a group call. And, they were just talking about they haven't written code in 16 years, but every day they're meeting with engineers and, giving them guidance on their problems and helping them understand if this is the right approach. And that's frankly where a lot of big success can come from. Now, is that to say that if is programming the bottom of a rung? It's no, not really. There's some really, really talented thinkers out there who are just really good at understanding software systems intimately. The kind of types that know a language back to front and are part of the development community and might be contributing to the open source of Python or something. That's quite extreme, but it's there's definitely space there, right? But out of however many students do a course like this, 1,000, not everyone's going to end up being a superstar for their awesome programming abilities, because they can write the best Python. Because for a lot of people, that's just kind of a spot. So anyway, that was a very kind of meaningful, though maybe slightly distracting tangent, which just kind of came to my mind then while we were talking about this, because I was thinking about negotiation, and it's that's why you're valuable. And I know this is kind of annoying, right? Because a lot of people get into programming, they're I love this because I can just sit down and write code and leave me alone, And it's you can do that. Thankfully we live in this great industry where you could just sit down by yourself and code, and you'll probably earn a bunch of money, more than most people, because of how affluent the software industry is. But in my experience, you tend to see better success for yourself if you actually embrace that there's a human element to things. And I've seen this as well in industry plenty of times. you have 4 engineers, they can all program fine, but the one who's actually interested in designing systems or even figuring out what the problem is and having meetings and whiteboarding and doing designs and asking questions and talking to customers and actually interviewing potential customers or clients, they're the ones who are by far more valuable on average. Camille says, how does requirements analysis tie into clients getting quotes for software work or a tender process? That's a great question. In the world of software engineering, you've got all this stuff from, I guess, on 2 ends of the spectrum, right? You're working as like a code monkey for Google, where you're on a team of a team of a team, and you're just writing code, and it's very focused on technical. And then on the other side, you might be working for some kind of consultancy or even a small business yourself that's just focused on producing work, right? I've seen this. I had 2 friends from uni who did 1511 with me. They went and started a company where all they did was build software for businesses. They just went out to random businesses who were looking for software, and they went and sat down with them for a few days, talked about everything they need, tried to figure it all out, and then said, this is how much it's going to cost, and then the business might say, yep, build it, and then they go and build it, right? So that first part there is all about requirements, and that's kind of where a lot of this stuff fits in. It's about scoping out the system. At the end of the day, an engineer is going to have to build the thing, but you tend to get better results when you have engineers part of the negotiation process. And you know what? It's not even like, they send engineers out into the big bad world to figure something out, right? Like when someone says, we need to move online. UNSW needs to move online. We need, Microsoft Teams and Zoom licenses and stuff. It's not like they just say to, engineering teams of people, go and figure that out. It's often that, there will be actual people who are product managers and other project officers who just work with engineers, So it's just a very useful skill to have because people will value your input and consider you much more valuable. So back to this. If we think about requirements engineering, the process of generating requirements as a negotiation process, as a very human process of figuring out what in the hell the goal and definition of success of the system is, you have to talk to stakeholders. You have to go and actually chat to people. And I'll give you an example. Again, in my role, which is looking after product and engineering for a financial piece of software, whenever we do stuff, we have a couple of key stakeholders, which are the engineers, customers, and our commercial or legal team. Because everything we do, we need to actually be interested in what our consumers, the people you're building it for, care about. That's you in the context of the uni, right? Most things that happen at the uni, they talk to students in some way. Maybe not enough, some would argue, whatever. That's not what today's about. It's like, they do it to some extent because your students are a stakeholder. You talk to engineers or you talk to your staff a lot of the time because they're going to be the ones executing on it. So when they do a move to trimesters at UNSW, they do talk to staff because they're going to be the ones dealing with it, and they get their feedback to understand what's a good system. And then in the case I mentioned about, a financial company, because a lot of what we do is very, has a certain level of intensity to what degree, finance is a big scary industry with lots of rules and stuff. You tend to need to talk to someone and say, can we do this? I'll give you an example. We were scoping out a system the other day to make it easier for people to save money into a thing, and we were going to charge them money at the start of the month. Let's call it $1 a month. $1 a month, and we'll help you save money and make that money bigger, right? I'm generalizing it a bit here because I can't talk about it, but and we went to the legal teams, and they were like, yeah, that's a good idea, but you can't charge at the start of the month. You have to charge at the end of the month. Customers won't care, right? Like most of the customers wouldn't care. The engineers didn't care. Most people didn't care, but from a legal standpoint, they were like, there's pretty strict rules in Australia that a finance product, you can't charge for services yet rendered. You have to charge in what they call arrears at the end of the month, right? So that's why this is a big complex project full of different stakeholders, because there are lots of different voices that weigh into this for different reasons, and it's all about bringing it together. So when it comes to this 4 steps of requirements engineering, I mentioned before elicitation, analysis, specification, and validation. At a high level, elicitation is about collecting everything. Analysis is about organizing everything. Like sitting down on a desk and piecing it all together. Specification is about coming up with something that's finished. And then validation is about going back to the same stakeholders and saying, how's this? Is this good? Does this capture everything? You know, and that's kind of like a fairly straightforward process. So if we look at elicitation, this is kind of one of the this is the most interesting as far as I'm concerned, because it's the one not talked about, which is just like, just learning what you can. Because again, when you come up with requirements, let's say again, moving UNSW totally online, or, you know, going to quadmesters or something, like four terms a year, or God knows what. You need to learn, and you need to ask questions. You can do market research. You can ask, you can do focus groups, right? So let's say I want to change 1531 in a way. What's a way we could change 1531? Well, we could remove the labs. You know, we could be trying to rethink about how the labs work and take all the marks off the labs. Okay, so, well, what's some things we can do? We can go and send out a survey, right? We can do some market research. We could go and put out a poll to all the students. What do you think of this? Do you like it? Do you dislike it? Do you not mind? You know, so there's a whole bunch of quantitative stuff you can do. You can go to focus groups, as in you pick, like, you know, say 3 students at random and another 3, and you do like a call with them, and you just chat to them about it. You say, you know, like, what do you want to see? And then you take some notes, and it's very deep, you know, meaningful and all of that. More detail. You're going to be subsampling, but, you know, there's more detail there, and you just collect information about it. You know, whatever that information is. Elicitation is about pulling as much as you can in. And you kind of get this, right? Like, who remembers doing, like, think about, another way I like to talk about this is, do you remember doing research essays in high school? I'm sure many of you did something like this in high school. Like, write a 4-page essay or report on the effects of acid rain in the northern hemisphere or something, right? Or like write a report on, you know, the impact of the World War II on the rate of physical science developments. I don't know. And, like, remember what you did. Like, you kind of went through this process for a whole different reason. It's not, I wouldn't call that requirements, but it's like, what would you do? You do a lot of Googling. You collect a whole bunch of notes sometimes. I know this is not how everyone works. You then start organizing the notes, which is step 2 analysis. You then start kind of coming up with a draft, which is like step 3 specification, and then you might get a teacher or someone else to look at it, which is validation. So this is a very natural process we all go through for a ton of things anyway. So elicitation is the most important, and it's the most human part of it. Analysis, as I said, is about, once you've got all this raw stuff, categorize it. Break it into different chunks. Be like, all right, yep, that's related to this, that's related to this. Figure out what are constraints and risks. There's no table I could give you here where it's like requirements analysis is just like identify conflicts and risks and dependencies, and that's it. Because different kinds of activities would dictate different things. Sometimes you would, sometimes you might categorize this into best case and worst case. So you think about the thing where I say to students, okay, let's have a look. Let's explore a different assessment structure. Bigger exam, smaller exam, bigger project, smaller project. You're going to go a whole bunch of things. Some students say, oh, bigger exam, that's so stressful. It's 3 hours of my term that determines my life. Then other students say, yes, please have a bigger exam. I'm in control of that and I'm not dealing with my group. You're going to get both of those things. You know, how do you weigh those up? How do you define those as risks? How do you collate them together? That could kind of go on forever. Ways you can build this picture here are actually part of our second lecture after the break, which is around use cases and user stories. So I want you to remember this point. Once you get a bunch of information from people, the analysis or the organization stage, we're going to talk about some more formal ways to do that soon. So, you know, this is just collecting it all together. Specification is saying, all right, well, let's actually get rid of the noise now and put something back together. You know, think of it like a draft summary of things. If you imagine for a second that, you know, when we write the project spec, we sit down, we talk to the tutors, and sometimes we talk to some ex-students, in particularly ex-students who become tutors, and we say, okay, well, what do you think's a good set of things this project needs to do? Oh, we should teach, we should give them some problems that if they don't communicate, they're going to do really bad at. We should give them some stuff that focuses on, this was written so long ago now, I don't remember what the specifics were. we should make them have a sense of storing data persistently. Stuff like this, and then you eventually come back and you produce a draft, and you might give that back to the stakeholders, right? But the actual producing of a draft production of a draft picture of things is essentially what this specification's about. It's actually bringing it all back together now. You've got it, you've analyzed it, let's bring it back together. And then lastly, we have our validation, which is like making sure you didn't stray off the path, making sure you're still doing the right thing. Go back to the stakeholders, say this is what we've come up with, and they'll say, oh, this seems to be missing that thing that was really important to me. And the answer there is like, you're right, that is missing that, thank you. Or the answer might be like, sorry, but you were the only one who cared about that, and we interviewed thousands of people. So that's kind of that process there. Now, what are some challenges that you might face in this process or experience? Well, I could tell you a few. One of them, requirements are sometimes only understood after designing or building has begun. You've probably noticed this from your own project or any other kind of software project. Sometimes you don't actually understand the goals until you work with it, and sometimes the goals change as you work with it. And this is a very soft balance here, and this is why we see this kind of iterative design in the world of software in particular, because the requirements are always changing, right? Think about this for a second. It's like why do the designs of websites change? Like, why does Facebook look different every 2 years, or why does other stuff look different all the time? It's because like the needs and the goals, the definition of success changes as people's tastes change, as technology changes, right? So there's lots of things that can't just be understood at the start forever. It's a constant renegotiation process. That's why we call it the software engineering life cycle, not the software engineering sprint. I don't know what you'd call it. Like, start, stop, go to sleep forever. Sometimes clients and customers don't know what they want. This is a really big challenge. Sometimes you will talk to students who will say things like, I don't like the idea for tech quadmesters because I don't want to do that. And it's like, maybe they don't understand how the benefits could be, right? Because everyone can only give as good feedback. Everyone's feedback can only be as good as the information they have to understand. Sometimes they change their mind. Sometimes developers might not understand the subject domain. Maybe you're trying to build a system for like online learning as like a network engineer or something. But maybe you don't know a lot about education. Maybe you don't know a lot about the life as a student. Who knows? Sometimes you see people design courses, like young people design courses for older people, and they get it wrong because they don't understand the context. Sometimes you don't have access to stakeholders all the time. You can't often just call people up. Sometimes you only get to ask them questions a few times because the people that you're relying on to help you determine the requirements are busy. Like you can't just be like, this random question. Sometimes you have to collate them up. That's why we get you to write an assumptions doc in iteration 1, because we don't want to clarify all of your assumptions for you, because it's very, very real that you can't just you run into a point of ambiguity. You have to make a decision on it, document it, so that it's written down somewhere. And you know what? Maybe in a week you could sit down with a stakeholder and be like, these are the assumptions we made. And they're like, yeah, they all look good. Yeah, that makes sense. No issues there. And then the last one is jumping into details or solutions too early. I don't remember if I've talked to you all about XY problem this term. I lecture enough that I often forget this. I believe it was talked about. I don't know, someone can remind me. I know we talked about it in 2521 last term, which I know some of you are from. But I do just want to mention it again because I think we're at the end of this lecture now and we can take a break. But I'll mention it again, even if I've mentioned it already and gone through it already, because it's very relevant here once again. Definitely mentioned it this term. I did. I know. I talked about this. I sent you the link to the XY problem. I think I talked about it with design or something like that. The thing I wanted to point out, right, because we already talked about this. I'm not going to talk about it again, run through it. But the reason this is really interesting is mainly in the world of requirements. And again, when it comes to this negotiation process, when it comes to this requirements elicitation from people, this is actually one of the most important things you need to keep in your mind. Because if you're talking to someone, you know, like a student or, you know, a client or a consumer, customer, whatever, and they tell you what they want, you have to be very, very careful that you're trying to extract from them the problem and not their desired solution. Okay, I gave you the example about the fork and the chopsticks, I believe. Yep. And it's like when you're talking to stakeholders and you're trying to extract what defines success, you have to be really careful. In DESN 2000 and 2020, you know, we kind of gave students this opportunity to interview, not real, like, you know, their friends and stuff. They were building like a smart Opal system in Sydney, like a smart transport tap system or something like that. And it was really interesting because it's human nature to go to people and say, you know, what do you want from this system? And they're like, oh, I really want this particular feature on my phone. But in actual fact, they do want that feature, but that's just because, you know, they have a problem that they want solved. So focus in more on that problem. So when you're doing this kind of elicitation, when you're doing this understanding and negotiation, focus really hard on the problem. Students don't hate trimesters, right? I mean, from my assessment, it's been going on long enough now that hating is just a meme and it's just life, right? Like, you know, everyone doesn't like change naturally, but it's like students aren't like trimesters are a terrible idea. That's what I hate. It's kind of like, I don't like being tired. I don't like feeling compressed. Even if I'm working the same, I don't like feeling compressed. I don't like doing, you know, one thing really hard for 3 weeks and then another thing really hard for 3 weeks. I'm the kind of person that would rather do 10 things slowly at the same time. You know, and this is really important when it comes to elicitation, because you often have to probe into people, and they say things like, I don't like this thing. I don't like online learning. It's like, okay, why? Do you feel isolated? They say, yeah. They're like, do you feel like you have access to less material? They're like, no. Do you think the education's worse? They're like, no. You're like, okay, so it's not that, you know, the requirement isn't that we want to avoid online learning. It's that community and connection is really important. That's your requirement there. So there's definitely an art to actually coming up with this set of requirements as part of this process, where you actually have to probe and learn more about the person. That's why I say it's very human. You know, it's not just like this mechanical process of jotting things down. So this takes us to the end of the requirements engineering lecture. Yeah. So let's take a break till 11 o'clock, 7 minutes. Fill this in. Please pause the video and fill this in. Thank you. For those watching live, fill this in too. That would be great. I might even have to update it for the next few lectures because I think I've changed some things around again. But yeah, take a break. We'll start up like 11:01 or something like that. Should be pretty relaxed. So cool. Thanks everyone. See you soon. Hi, welcome to 7.2, where we're going to be talking about use cases and it's the lecture over. Use cases and user stories in relation to requirements. So again, we've just kind of finished a lecture on looking at requirements most broadly, and now it's a very specific lecture on how do you capture them. You know, what are some specific ways to actually capture those requirements? Because you could just write them down, you know, like we could go through an activity like that together where we just write a whole bunch of requirements down as plain text, but there's some standardized ways out there to capture some of those goals and habits and everything else from the elicitation process. So let's have a look at both use cases and user stories. Now, in the world of requirements analysis, requirements engineering, we have a priority these days, more than ever in fact, to capture things in a very human way. This has been a growing trend, I'd say over the last, 10 to 20 years, where, you know, you look at the ADRs, the road legal stuff I put up earlier on like one end of the spectrum, and it's like, okay, that's very inhuman, you know, it's very kind of sterile, mathematical. And then on the other end, you have things like maybe a requirement could be that, you know, this app needs the user to feel like they're accomplishing something. You know, it's like, what does that mean? Well, it's very human, but here's the thing. Most times, not always, most times many of you are going to work with a set of requirements to solve a problem. You're going to be doing that to solve a problem for a person. And that person is a real, you know, thinking, feeling human. So we're going to look at use cases, user stories. This all falls under the requirements analysis part of the SDLC, but it also is used very commonly in the design part as well. So when you're actually looking at design, you do look at the requirements and think, what's the actual, you know, set of goals we need to do? And then we build a software system around it. Because you can kind of understand design as, you know, building the software system, dictator, like figuring out the right high-level conceptual way to build a system coming from those requirements. So I've got these the other way around. So we're going to start off with user stories. Now, you might have heard of these before. They became really popular in the world of Agile and, you know, that whole Atlassian gold rush, Trello, Jira, everything else. User stories are a method of requirements engineering used to inform the development process and what features to build with the user at the center. Right? That's the most important part, with the user at the center. So they are just a certain way of writing a requirement. There's nothing fancy about them at all. It's just like, rather than writing something kind of really boring and sterile, it's a way of describing a requirement from the perspective of an end user. So we try and bake them in from the get-go. Now, in terms of the structure of user stories, if you're writing a requirement for a user story, it tends to follow this pattern, which is that as a type of user, I want to achieve a goal for this reason. That's kind of the common structure of it. And why this matters is because we mentioned that use cases and user stories come up in the analysis part of requirements engineering after you've done the elicitation, because if you've talked to students, and you talked about, what ways can we improve UNSW for you? And they come to you and they say things like, I want to be able to purchase monthly parking passes online. You could write that down as a requirement, right? So what could you do here? You could say, well, let's write that down. A student shall be able to purchase monthly parking passes online. You could go that one better and say, why? Again, think about XY problem. It's like, why do you need to be able to purchase them online? And they say, oh, because I hate purchasing them in person, or I don't like purchasing them online every day. And that could help refine your requirements. But let's say that this is a requirement itself. If you wanted to write this as a story, as a user story, you could rewrite it as a student, that's the category of person who you're engaging with, I want to purchase a parking pass. That's the goal, right? If they've purchased the parking pass, tick, you've achieved it. That's the definition of success. You have succeeded. And then the reason, so that I can drive to school. That one's really important because a lot of kind of classic requirements analysis often omits that, and it just kind of can write things down as like, this is what needs to be done. This is what a consumer end user needs. But understanding the reason why it matters is really important. So again, the growing trend towards engineers, designers, system engineers, like software engineers, actually understanding the motivation behind the goal definition is considered really important now. Whether it's written formally as this user story structure or not, like understanding the what motivates them is super important, because you think about how much, this kind of comes into everything from visual design to engineering development. It really helps paint the picture. So that's the structure of user stories. They're written in non-technical language. They're not meant to be like the ADRs that I showed you earlier, where it's like, this and this. They need to be able to, purchase it monthly online, but, assuming the service has an uptime of 99.9%, or, purchase monthly parking passes at any time of day or this URL. It's meant to be very kind of high level, non-technical, and user goal focused, not on product feature focused. So where possible, you want to make the goal as problem focused as you can and not solution focused. So maybe this is the problem, that there needs to be a parking pass purchase. But think about this. It's like, you could have this requirement another way. As a student, I want to purchase a parking ticket on the UNSW website. Maybe that's what they say to you. But it's like, maybe they've just said that because that's where they just assume that it should go. But in actual fact, they just want to be able to purchase it quickly. I want to be able to, with access to the internet, I want to be able to purchase a parking pass. Maybe that'd be better done on an app. Maybe that'd be better done on a website. Like, who knows? Maybe that could be done at the actual pay, at the entrance with a tap. Like, you want to keep these goal focused. Sorry, I went the wrong way. You want to keep these goal focused, not on feature focus. Because one thing that end users will always tend to do is to tell you what features they want. And your job is to extract that out, like we mentioned before. And user stories are no different. You'll see this come up in iteration 3 too, which we'll talk about kind of briefly tomorrow. Because in iteration 3, we do actually do a little bit of requirements analysis. Well, we do a little bit of requirements and design, essentially. So we like this because it keeps it problem focused, it keeps the customer at the center, and we probably won't do that building. Oh, maybe we'll do that to-do list activity, actually. Blake says, how does the reason affect the later design? That's a good question. The two simple examples I could probably give you there are that, if someone says, I want to purchase a parking pass so that I can drive to school, you think about someone who's doing all the comms or the copy or the visual design. Maybe the angling of how all that's conveyed is, beat the bus or, get to university even quicker now or something like that. Because if you can understand, like, you know, if this website's not about, I mean, there's a great, I mean, a bunch of you would have seen it, but there's a great Simon Sinek talk. It's an old TED. Is it old TED video? I don't remember. I saw it once many years ago. Yeah, it's an old TED one. This is kind of, I think, when he was, I think this was one of the things that made it famous. Anyway, he talks about, like, start with the why. This is what the talk is. Talks about, like, from a communication perspective, people tend to respond most to the why you're doing something or why something exists, and then it's the how it works, and then it's the what it is. You know, and the case study I think generally used there were like Apple computers. I'm not a massive Apple fan, but you know, I get the appeal, right? Because it's like, well, you don't build a website saying, you know, parking, easy parking, because that's all cool, but it's like, you know, why are you doing that? Why do they care? Like, you know, people don't wake up every day saying I want to park easier. Like, no one wakes up every day saying, God, I really want to eat broccoli. I mean, some of you might, but people wake up and say, I want to be healthy. Yeah, like, that's the why. So to your question, Blake, how does this affect the later design? It affects it because, you know, even though you can help them achieve their goal, maybe you can actually paint a broader picture around it in terms of the design. In terms of the engineering front, sometimes it just helps ask questions in the team around, well, if this is just for parking and they're just trying to get to uni quicker, maybe we should have some other maybe we could build in some other capabilities early on. So the short answer there is sometimes it can help you potentially future-proof things a little bit. I think future-proofing is somewhat overrated generally, but yeah. Waleed says, just a bit curious, the story we made for the student implies that they could buy only day passes. If they could only buy day passes, they would not be satisfied, which is not the case. Is this fine or not? Well, I don't know. You'd kind of have to talk to the student. This is kind of just a made-up example. Like, you could talk to them and they say, oh, yeah, I want to buy day passes too. It's just like monthly is like the most common one. And you're like, oh, cool. Well, let's change or maybe I'll write 2 user stories. As a student, I want to purchase a day parking pass so that I can drive to school occasionally. You know, and then the other user stories, as a student, I want to purchase a monthly parking pass so that I can drive to school regularly, or something similar. Oh, sorry that I missed that one, Diora. So, says, to what extent do you go to when writing requirements? If you have some foresight and see areas that are outside the current scope that will be required later on, do you still present them? That's a good question. So just to recap for everyone, that question was like, you know, do you only work with what you have, or do you think deeper than it? If you have suspicions about what might be needed in the future, your job is to elicit that information from people. So I guess the short answer I could give you is that a set of requirements should come from what stakeholders have asked for, not from your intuition, the vast majority of the time. But if you feel like something's missing, it's kind of your job to go back to stakeholders and to do that research in theory. So, you know, if you're like, oh, actually, we should really invest in this kind of thing. You know, like say that uni's moving from semesters to trimesters or something, and you're kind of like, I feel like we should really think about this even more broadly. Maybe they'll do 4 terms, 5 terms, 6 terms, rather than just kind of building that in as like just in case, which I think is a very slippery slope. You would actually go back to stakeholders and say, you know, we wanted to check about this. Is this at all feasible? And they might be like, maybe. Or they might be like, yeah. How'd you know? Or they might be like, no way. Absolutely not. They'd be like, no one's ever done that in the world. There's no precedent for it. So we're not doing it, you know. So it's really like a go back to them to figure that out. Because the big thing in a lot of this, and this is where all this requirements and user stories comes back to, is that things need to be properly motivated. You know, like I'm not a big believer in software for software's sake. I think so much software is written poorly, or it's deleted, or it's never used, or it becomes confusing, or it becomes buggy, that it's like, you need to always make sure that what you're doing is properly motivated. And I would have this view more than probably a lot of other people, particularly in academia, but it's just something I see all the time. So it's like an example again. Someone said to me the other day, I'm half changing up this example. They were like, we're using an older version of Flask. We should really upgrade our version of Flask. And I'm like, why? They're like, because it's good to have newer versions. And it's like, why? Like what? Like, why? And they're like, well, there might be some features there that are useful. And I'm like, well, upgrade it once you find these features. Don't just kind of do things because you have a suspicion about things. Actually go and make sure there's a good reason to do it. Camille says, if a client insists on a particular feature which you don't find matches with their problem, how do you finish the requirements analysis? That's a good question. I'm answering some questions now. So just to be clear, we've talked about what a user story is. We'll run through a quick example of maybe making some in a sec, but I'll just answer Camille's question first. So again, if a client insists on a particular feature which you find doesn't match with their problem, how do you finish the requirements analysis? That's hard. So let's say that someone has a problem like trying to think of what a good example of that would be. Say they want a messaging app, like your UNSW stream stuff, and you can tell that their problem is that they want to be able to send direct messages, like group direct messages, and then what happened? That's actually probably a good example. They're like, I want to be able to send group direct messages. I want to be able to pick like person, and send them a direct message. And you're like, what's your problem? And they'll, and you talk about it, and you realize that what they're trying to do is they're just trying to find an easy way to message a few people, and they want it to be a separate thing from channels. And you're like, well, it doesn't need to be separate. We could simplify all of this just by having direct messages be a channel itself, right? Like when someone creates a DM, it just comes up as another channel but the channel name is just the DM name. And you might look at this and you might talk to them and you think, that's so stupid. They just don't know the best way to solve this. They have an inelegant solution. And this happens all the time, and it also happens particularly with engineers, because as engineers, you probably don't realize how smart a lot of you are, because you're very analytical thinkers, you're very logical, you're very good problem solvers, even if you feel not that way sometimes. So there is a tendency to kind of want to override some of those ideas, but it really kind of comes down to how widespread it is. If you're talking to 100 different users of your system, or potential users, and 90 of them say, I want to have DMs and channels separate, and you say, you understand they're the same thing, right? They're just different names, kinda. They're like, yeah, I do, but it just makes sense to me. Well, you're building it for them. You might as well do it. You know what I mean? Like at the end of the day, most things you build are to make someone happy, because if they're happy, you get more job, you get more money, you get more promotion, you get more they're there at the end of the day. If one or two people are asking for it, you'd probably just say, I've listened. We think we found a more elegant solution that most people seem to be satisfied with. And that's normal. That's normal to come back to people and say, I understand you wanted this, but that just wasn't what the research indicated to us. Yeah. And a lot of this stuff is covered. I think it's in DESN 2000 now. So that's good fun to watch. Yeah, the whole customer's always right thing. I don't... like you read up on things, I think Amazon, you'll see Jeff Bezos say stuff like, I hope he says it, listen to the customer. Aggressive, listen to the customer. And then you look at Steve Jobs quotes, and it'll be like, people don't know what they want. People need to be told what they want. Stuff like I don't know the exact quotes, but you'll see that kind of stuff. And this is why I freaking hate quotes from famous people and stuff, because it's like, they're both right. There's lots of times where I'm sure both companies has been very adaptive to people, and both times where they've taken a stance on things. They've been opinionated. So yeah. Anyway, let's just have a quick example about user stories and building a to-do list. Now, I think the to-do list problem is interesting to me because I think I would call it. I refer to it as the unsolved problem, where there were lots. There are unsolved product problems, I believe, and one of them that was interestingly solved to me was Slack and Teams and all of that, because prior to 2015, right, Discord and all this stuff. Well, not. I don't know how long Discord's been around. I know a bunch of them have been around a lot longer, but they didn't get very mainstream for a long time. It's only been like the last 5 or 6 years that they've really picked up. Discord 2015 too. So Discord was released. I'm Googling this on another screen. Slack was founded, like Slack was initially launched. I'm just looking this up now. 2013, Microsoft Teams, Wikipedia was launched. Who even knows? History. 2017. Like, these are all very new software, or pieces of software, right? And before that, there was nothing really there for it. Like, really, like, it's kind of actually crazy. Sometimes I think about the fact that when I think back to like some group stuff I used to do, like everything we used to do was either emails or Facebook chats, which is just like, if you told me to do anything with anyone via email or Facebook chat that was highly collaborative, I just like totally melt. So I think that problem was solved. Discord, Slack, they like solved the the direct messaging problem. What problem I think still isn't solved though is a lot of the to-do list problems. I've never really seen a to-do list app that has just like totally taken the market and everyone loves it. There's a whole bunch of them, and some people like certain things and some people like other certain things, but there's just nothing that really like nails it. It's like fully integrated, all of that. So let's build a to-do list. So what I want you to do in the YouTube chat is I just want you to like think about a nice to-do list. Don't tell me user stories. I'll help you. I'll help write them for it. But I just want you to tell me, like, what do you like in a to-do list? When you think about a really good to-do list, what do you think it has? How does it make you feel, and like why? Just like tell me a few things in the chat. While you're typing that, I'm just gonna respond to a couple of the other comments. So like Justin says it's very similar to branding, logo design. Customers think they know better. Yeah, that's true. Izzy says yep, it's very difficult with things like games and stuff too, because people complain if things don't change. People complain if things change. I mean, I see this in teaching. You eventually get used to it. People are annoyed about everything. So, okay, so I'm gonna write some of these down. Let me just open up a fresh window for us to write into. We'll write some user stories together. Just gonna copy some of these in. I will only copy another few for now. Okay, I'm just Luca is the last one I'll copy. So, red. Oh, I feel so bad. Not. Okay, I'm actually gonna stop now. I'm sorry. We're only gonna be able to do so many, but let's have a look at some of these, right? So, Hussein says, reject to-do lists, return to I'll remember this. Are you just saying we don't want a to-do list? Is that what you mean? I don't know. Okay, I'm just gonna get on that. Marker on hand. Okay. Well, fair enough. Like, well, again, in theory, you should start this and say, like, is an app really the best way to do this? But let's assume we're doing an app for a second, or some kind of digital tool. So I think it's great that there's, a bit of like using a marker and pen and paper, because sometimes that is the best answer. But let's say we are trying to create a billion-dollar business with like totally everything, etc. Vincent says, I like the ability to organize the tasks visually. Okay, so and most of these things are like, who are you? The hardest part of a user story for most of I guess students in this course, because we asked you to do this as part of iteration 3, is they say, who's the type of user? Like, I get the whole goal and I get the whole reason, but like, who's the type of user? Well, it depends what the context is, right? Like, in the context of all of you, I'm asking you probably as university students because that's what most of your life is entailed. But different people might have kind of different backgrounds. So I might say as a uni student, I want to organize my tasks visually. I don't know. To do. Not sure what Vincent, why that matters to Vincent. I'd be curious. Vincent can probably tell us. Camille says, as a uni student, I want to be able to check boxes off. And I'm just going to make the assumption here because it's motivating. Something like that. That's the main reason I think most people want to check things off. Yep, makes you feel satisfied when you complete a task. So I can see here, maybe I'll just mark these as like how many people, right? So let's just call this person like one person. As a uni student, I want to be able to check boxes off because it's motivating. It's because it's motivating and satisfying. I want to be able to check items off. I should call it items, right? You don't want to call it boxes because boxes is more constraining, right? You don't want it to be feature oriented. You want it to be goal oriented. I want to be able to, or even better, mark items as complete. Now that's a pretty obvious one. So 2 people kind of have touched on that. If I make a to-do list, I never look at it again. Ability to break down tasks into subtasks. Okay, so Fu, as a uni student, again, I'm not sure what the motivation here is, right? I want to be able to break tasks into sub-components to organize my complex. I'm just making this one up because I can't go back to all of you. I don't know, to organize my complex tasks. I don't know what you call it. Proper calendar integration. As a uni student, I want to integrate with my calendar. This is the kind of thing that you would kind of go back to someone and be like, well, what does that mean? Like, what do you mean by integrate with calendar? Like, if you gave that to someone, they'd be like, what? So you'd have to kind of go back to the stakeholder, Fu in this case, and be like, why? Gorbs also said the same thing. Crystal said reminders. Able to open from any app with the single keyboard shortcut. I like that one. As a uni student, I'd be curious on the why again. I want to open the app I want to open it anywhere with one keyboard shortcut so that, I don't know what the motivation here, so that it's easy to quickly jot something down before I forget. Now, I'm just going to stop there for a sec because I'm hoping this has kind of demonstrated things a little bit. And I think a few of you have probably... it's so funny, Brianne, about the whole I want to make tasks repeat every X days. It's like, this is literally my problem right now because there's these things I have to do every day, and I've literally tried to like write a whiteboard for it. And I'm like, this is so annoying because I just want to check it off, and then every day I wake up, I want the check boxes to disappear, but it's like, I'm not going to rub them off every day, I'm just going to forget. So like, this is why it's interesting, because different people are different, they have different needs, and if you ask this broadly enough, you can start to actually paint a picture of what it is. And this is requirements analysis. This is, you're eliciting stuff, I copied it down, think about that like step 1. Step 2 is actually analyzing it now. It's just that what's happening this time is that as part of that requirements engineering, right, this analysis you're doing with user stories. You're trying to write it in a particular structure. Google Calendar tasks for repetition. Thank you, Blake. I will look into that. That's a good idea. So, hopefully I've demonstrated... that's okay, I'll need to do it every day anyway. Hopefully I've demonstrated that well enough. When it comes to user stories, we want to ask ourselves a more important question too, which is like, how do we validate user stories? How do we know we've met the requirement? So we write a user story down. How do we actually know if we've met the requirement? Now, a big part of this, funnily enough, is actually writing better user stories. If you write a good user story, it's really easy to tell whether you've met the requirement because it's just so straightforward. So testing how you've met the requirements actually somewhat easy. We'll get to in a sec. But in the meantime, we want to focus on just writing a good requirement. Now, What's a bad user story? This one. I want to integrate with a calendar. This is a bad user story because every requirement you write needs to be testable. If you can't look at a requirement and think, I know how to test this, I know how to check it, be like, yep, that's done, you can't achieve it, right? So we need to think about our user stories in this INVEST framework, which is that user stories should be independent. They should be as small as possible. You shouldn't lump them together. They should be negotiable, as in they should avoid too much detail, because if they avoid too much detail, you're going to constrain your solutions. They should be valuable, which means they should hold some value to the client, because if they don't, then the client's never going to care if you do it. So it needs to matter to the client. They should be estimatable. We actually don't cover this anymore in the course. I should update that. But estimatable is kind of like you should be able to have a sense of how much work is involved in them. They should be small too, so that they aren't too big and too broad. The small one kind of comes back to this. This isn't really a small thing. Like integrate with a calendar, it's either unspecific or it's not, like it's too big. And then lastly, they should be testable. Now, testable's an interesting one because like literally every time someone gives you a requirement, you should be thinking, how do I test this? Whether it's a user story or not. If you can't figure out how to test if it's happened, you shouldn't do it. Like, it's just a bad requirement. Sorry. Paracetamol. So it's like that's kind of the crux of it. They should be small so they aren't big. Yeah, they should be small so they aren't big. It's kind of funny because in general they need to be small but not specific, not too detailed. Sorry. So you want them to be like these small little nuggets, but not like overtly like you have to do exactly this, because you want to leave room for designers and engineers to figure some things out. And on the testable front, it's like, well, you look at these, it's like I want to organize my tasks visually. Yeah, that's kind of testable. You could probably give someone an app and say, do you feel like you can organize these tasks just by playing around with it? I want to be able to mark items as complete. That's clearly testable. Break tasks into subcomponents. Yeah, that's testable. Integrate with a calendar, maybe open it anywhere with a keyboard shortcut. Yeah, that's also kind of testable. Blake says, wouldn't give it to a user and see if they like it always work as a test. So that's a good question, Blake says. It's kind of like, we've got all these little mini things that we say should be testable. Why don't we just give them the finished app and we say, do you like it? And they go, I love this. And you're like, great, we did our job. The reason you got to be careful there is because that does not help you derive which of these user stories actually had an impact and which didn't. Because some people could love an app, but maybe they don't care about a particular thing you did. And from like an engineering management point of view, it's really important to understand like whether what you do has an impact. Because otherwise you're just coding blind. Like if you've written code that works, that doesn't actually have an impact, it's pointless code a lot of the time, right? So that's the kind of thing to be, thoughtful of. The last thing here is, just kind of glancing through this. The last thing here on user stories is just around user acceptance criteria. User acceptance criteria is something that you write as part of a user story to help kind of define the tests. So I mentioned before that a user story should be testable. Well, it should be testable because you know what to test. And user acceptance criteria are essentially criteria that you can test against that you write in like fairly natural language. So as an example, if I have a user story here that says, as a user, I want to use a search field to type a city, name, or street so that I can find matching hotel options. That's the user story. It's kind of broad, but how do I tell if it's successful? So what's this testable component, this part up here that I wrote in bold? Well, we can write some user acceptance criteria underneath that says things like, the search field's placed on the top bar, search starts once the user clicks search, the field contains a placeholder with gray colored text, where are you going? The placeholder disappears once the user starts typing, etc. Now, this might be done by a designer. this might be done somewhat after the requirement stage, and you can actually see this here. It breaks down a user story into criteria that must be met. It's written in natural language, and it can be refined again before the implementation. So sometimes you might write a little bit of this, you might write none of it, you might write a lot of it. This is important because it's very hard to test things like, I want to organize my tasks visually, because this might be made up of a few different pieces of criteria. Like, I want to be able to reorder my tasks. I want to be able to drag and drop into recycling to remove a task. I want to be able to insert a task between any other tasks. You know, you don't always want to insert them at the end and drag them up. You know, and some of this you can actually derive from customers as well. You know, sometimes you could argue that this might be for the design team to actually figure out what they think defines success, or you could say that it's part of the requirements, part of the elicitation, part of the talking to customers here. So that's what a user acceptance criteria are. They're just ways to kind of break up a user story into clear testable points. Your acceptance criteria should not be too broad. They should actually be like quite specific, as the example I gave before might be a little bit specific, but even then it's like, they're better to be specific because this is the actual testable part of what you're doing. So someone needs to be able to meaningfully test it. The actual testing of this is what we often call user acceptance testing. Back in week 3, when we talked about verification, we talked about unit tests, integration tests, system tests, and then user acceptance testing, or just acceptance tests. And this is where you would actually sit a customer down or a user down and give them your criteria and maybe say, you know, tell us if you think you can do all these things. Tell us if this meets it. And then you might ask them to, you know, do you feel like you can actually organize this? Sometimes the actual criteria might be all a tick, but they say, I still don't feel that way, you know? So again, it's very human. These are loose structures. Different organizations would deal with these things differently as well. Some of them would do it very loosely. Some of them would not do it at all. Some of them would do it in like, they literally follow a textbook or something. So, you know, best practices is just, they can't be too broad. And they're generally going to be more technical and specific than the actual story itself. I've just kind of talked about this. I jumped ahead here a sec. So it's like I mentioned, acceptance tests are there to ensure that the acceptance criteria have been met. So, you know, acceptance testing is the process of checking the acceptance criteria has been met. Pretty straightforward. Because user acceptance tests are super high level, they're obviously black box tests because actual users using your system, they're barely even going to understand how it works, right? Let alone looking at functions or anything like that. Some other examples are like, as another user story, you might say, as a user, I can log in, I want to be able to log in through a social media account because I always forget my passwords. I love this user story because it's really simple, right? Why do people like Google sign in, Facebook sign in, LinkedIn sign in, Apple sign in, whatever other sign-ins, Office, Outlook, Microsoft sign in? It's because they don't like remembering passwords, right? So that's a good user story. And then the acceptance criteria might be, can the user log in via Facebook? Can they log in via LinkedIn? Can they log in via Twitter? So that one might be a little bit simpler and like a little clearer cut for you. So when you're actually testing that with someone, you need that criteria because your design team and your engineering team are going to obviously implement some of these. And you need to know which ones to implement. And you can implement the ones that will allow you to pass the criteria. Where did this list come from? Well, ideally it would have come from talking to customers. So maybe you survey them. Maybe you survey 1,000 customers and you say, which of these services do you tend to log in through the most? And you notice that the most popular ones are Facebook, LinkedIn, and Twitter. You know, that accounts for like 95% of customers can log in with one of those 3 things. So, you know, as a team, you're like, that's our requirements. Now, there we go. It's in our user story. It's in our criteria. Hand it off to some designers. You don't care how it looks. That's the designer's job. You don't care how it's built. That's an engineering job, etc. Now, in terms of the acceptance criteria we've given before, like this one here, these were very factual. These were very much just like, can do that, can do that, can do that. I also just want to quickly talk about scenario-based acceptance criteria. The reason I want to talk about this is not because it's like there's 2 ways to do it or something. It's because I'm trying to demonstrate to you that there's a big, rich canon of ways people deal with this. Some people would just write it like this. Other people would be quite adamant on that our acceptance criteria should be describing things in the given, when, then syntax. Given, when, then is like, given a setting, when an action happens, there's a result. So now an acceptance criteria for, say, this user story, as a user, I want to be able to recover the password to my account so that I will be able to access my account in case I forgot the password. Okay, is that a good user story? Maybe. A couple of things that I don't love about it are, able to recover the password to my account. As you've all kind of probably learned, that's generally considered bad practice. So maybe you talk to the customer and say, wait, sorry, do you want to get your password, or do you just want to be able to change it if you forgot it? And they're like, oh, I'd change it. I just need to be able to log in. And you're like, oh, cool. Okay. So that would maybe change how the user story is written, right? I want to be able to gain access to my, like maybe a better user story here is, as a user, I want to be able to gain access to my account if I've forgotten my password, because I forget my passwords regularly. That might better capture the requirement. That's why this is a very human, intellectual process. But in terms of the user acceptance criteria here, in the scenario based, this one's written as like, the scenario is that I've forgotten my password. So given a setting where the user's navigated to the login page, and then they've realized they've forgotten their password, and they've entered a valid email to receive a link for password recovery, then the system should send them a link to the entered email to get their password. Also, given when the user received that link via email, when they navigate to the link received in that email, they should be able to set a new password. Some people would say that this is kind of a lot more readable, paints a better story, which we're about to talk about with use cases too. Blake says, are acceptance criteria always objective things? They're always testable things. I don't really know how to answer that in terms of, is it objective, but they're always testable things in terms of, yeah. I don't really know how to say objective or subjective there, because it's just, you could argue there might be some subjective things that are, like, what's an example of a subjective thing you're probably getting at? Is that thing like the user feels happy? Like the user feels relieved. When the user, then the system enables them to set their new password, then they feel relieved. I think generally you'd probably avoid that sometimes, because how do you test that? Survey them. It's doable, right? Like, you give them a pop-up after they reset their password. How do you feel? They'd probably be like, what? Thank you, close, skip. So, maybe is the short answer. You just got to use some common sense with whatever it is. So in terms of these examples, should you use this, what we call rule-based acceptance criteria, which are the ones where we just wrote like, has to do this, has to do that, has to do this and that and this, or should you use like scenario-based acceptance criteria? Dunno, depends what you're doing. You know what? Some companies do unit testing, similar to what you do with you've done with PyTest. Other companies do behavior-based testing or scenario-based testing, where they actually literally write tests in terms of like, here's the setup, here's the action, here's the result we expect, in a very structured way. So, you get to use which one you think makes the most sense, or more likely which one that people smarter than you think is more appropriate for a particular environment you're working in. There's a whole bunch of other reading you can do here. You don't have to. I generally tell you when I think links are worth absolutely clicking on, like I did with the functional, non-functional. This is just here in case people have some more questions. Now, on to the last part of this lecture today, which is on use cases. Use cases are another way of representing. Use cases are a way of essentially describing a scenario. Right, so is this like a different kind of user story? Not really, maybe, kind of. These are all tools that help you effectively communicate requirements and how a system should be, or how we intend for it to be interacted with. Use cases are a dialogue between a user and a system that helps people understand what that interaction is, right? It typically consists of a series of actions and reactions between what you'd call agents or individuals. What's an example of that? Well, it depends how you want to do it. We're going to look through a written example and a diagrammatic example. There's lots of other ways people might write it. Again, There's a whole spectrum of approaches to this, but let's start with the diagrammatic style, because this is arguably something that's kind of a little bit more maybe natural to you, because it's how you picture it. Let's say you're designing an ATM, right? Someone says, I need you to build an ATM, and you're trying to come up with a set of requirements to help you understand the nature of the system. It's like, okay, well, you might go and figure out all these things like, how much cash, what's the maximum cash you need? What are all the different things you need to do? Maybe you could write these down as user stories. The one other tool that's really useful is use case diagrams, where you actually can, it doesn't have to be, you don't have to like make cartoons or whatever, but it's like, here is like a storyboard where it's like someone comes up to a machine, it asks them to enter their PIN, the user types in their PIN, right? The machine goes and talks to a company server that says, verify this account. The company server responds and says, yep, there's the balance. The machine comes back and says, hey, I'm good. How can I help? The person says, I'd like to withdraw $60. The machine says, here's your cash. Person grabs, you know what I mean? Like, you're telling us, like, it's a scenario. It's actually very similar to what we saw back here, where it was like, given this, when that happens, do this, and so forth. So it's really just a way of describing behavior in a system. Now, why do you need this? Why would you ever want this? Maybe requirements are enough. Maybe user stories are enough. Well, whatever you think you need to adequately communicate and document the goals of the system, maybe this is included. I use use case diagrams sometimes. I don't do them like this. I'll often do them as flow charts and stuff, because I don't want to draw little kind of weird looking people with coats and top hats. Not top hats? Is that a top hat? I can't even remember what a top hat is. And briefcases and whatnot. But it's just another tool to help you communicate how a system should function. Now, you can also use a written form of use cases if you want to. So, rather than be like, here's a diagram, you could actually say, well, here's what we deem as a successful scenario. Step 1, ATM asks customer for PIN. Customer enters the PIN. ATM talks to the bank to verify it. Bank responds and gives you the balance. ATM says to the customer what action should take. Step 6, customer asks to withdraw an amount of money. 7's dispense. 8's the ATM tells the bank. Now, is this better or worse? Who knows? It's different. It's not going to be as useful for visual people, naturally. The good thing about this is it's a lot more specific too. You can actually get into some specificity here and some detail. One of the downsides, though, is you do often lose a sense of the agents involved in something like this. Another way you might draw these diagrams is you might draw them, I can't remember what the name of these are, but you might draw them like you say, here is the customer, here is the ATM, and here is the bank. And what actually happens is that, you start off and you're like, well, the customer talks to the ATM, and then the ATM talks to the bank, then the bank talks to the ATM, and then the ATM talks to the customer, then the customer talks to the ATM, who gives them their cash, and then the ATM talks to the bank. And you might write something on top of all of these, right? Like customer enters PIN or something like this. Sometimes these diagrams are super useful because these are most useful when you are trying to actually give a better feel for the participants involved and the interactions between the participants more than the detail of the interactions. This might tell a story in just a different way. So, there is no better or worse here. They're just kind of different ways of going about these things. Camille says, are use cases or user stories more commonly used? They're kind of just used for different purposes. Like, user stories might be there to capture a whole bunch of stuff. Like a whole set of requirements. Use cases would probably be there more to paint together a bigger story or explain a complex set of interactions. Because the thing about things like user stories is that they're all like atomic, right? They're all like, here's the thing. It would be really hard to describe this in a user story. You could describe it as like 4 user stories, but then you lose a sense of the narrative, ironically, right? You lose a sense of the story. Or you could write a big user story saying, as a customer, I want to be able to withdraw money from the ATM so that I can get cash to buy things. And maybe your acceptance criteria actually outline some of these key steps. So, it's no real answer about which is more commonly used. They're all just tools. And the reason I like to teach it this way too is because, like, I don't like the idea of being like, here's the 2 methods to do this and here's the whatever to do this. It's like, no. Even you have a problem to solve, which is you need to communicate a set of requirements without losing information. You could do that other ways too. There's, that I wouldn't have even thought about. Blake says, how comprehensive would be the use cases, since there's often hundreds of possible interactions with the system? That's a really excellent question. So typically, when we describe use cases in general, which also tend to fall into testing, we have what we might call the happy flow or the primary flow or the main success scenario or something like this, which kind of dictates, what is just the standard interaction people have, right? Like, you've gone to the ATM, you've put in your card, it asks you your PIN, you enter your PIN, it asks you how much cash you want, you type it in, you get the cash out, you go away. So you can always usually write a use case for like that main flow. Do you need to write a use case for every type of different permutation? Probably not. You could take a diagram like this and you could maybe annotate it. You could maybe say, you know what, at this stage here, B, perhaps the pin's wrong. Maybe you need to do a flow for the wrong pin and a flow for the insufficient balance. Maybe you only need 3. Maybe you could just have 1 and again annotate it. Like, a few different ways you could go about it. But no, generally, there's no expectation that you kind of produce hundreds of these or anything like that. Typically, it'll only be 1 or 2. And a lot of the time as well, the aim of a use case diagram or text is not to describe all the possibilities, because you can handle that through just kind of written requirements. It's to communicate a lot of the time. It's so that someone looking at this is like, oh, I get it. Because what did we say? What did we say back in this lecture here? Right? At the end, we said one of the challenges was developers might not understand the subject domain. That's another reason we like these use case diagrams. I was talking to a company that does banking a month or so ago, and they were telling us how easy it was to work with our team because we were all local Australians, and the reason for that wasn't racism or anything. It was because they were saying that when they work with other teams, particularly in Southeast Asia, like Manila, they don't get Australia's banking system. So they don't actually have a sense of the flow. They're all very talented people, but they don't actually, they've never had an Australian bank account and have seen direct debits happen and seen deposits happen and BSB account numbers. They have different names for it, right? Like in the US, it's routing numbers and various other things. So it's like sometimes use case diagrams are simply there not to, maybe this is already captured elsewhere, but it's a communication tool where someone's like, oh, okay, I've never used an ATM before. I get it now. That makes sense. Vincent says, so user stories and acceptance criteria there to outline the requirements whilst use cases there to show how the solution will behave to satisfy these requirements. That's a good question too. Maybe. This one's really hard. I actually had a hard time with this lecture because I think user stories unambiguously fall into the requirements category. Sure, some acceptance criteria you could argue might be a design decision. But these aren't siloed things, right? This is a fluid process. Use cases I found hard because I think, some people would say that it's in the design category where maybe these are captured elsewhere, where the requirement is just, oh, I want to be able to get cash from an ATM. I want it to be secured with my PIN. If they don't have enough balance, it gets rejected. If the PIN's incorrect, it gets rejected. They should be able to print their receipt, no receipt, or view it on the screen. Maybe that's the requirements, and that could be captured with user stories. And then maybe someone takes that and says, let's actually build this system, let's design this system. And then that person actually writes this out, and they're like, this is my design for the ATM to meet those requirements, right? So the short answer there is it depends, right? Because you could draw, these are just diagrams. I call them use case diagrams, but they're just diagrams that tell a story, or they're just text that tells a story. That story could be derived from this has to be done in this way. Maybe there's regulatory reasons for it. Maybe this is how all ATMs need to work in Australia, for instance. They all need to ask for the PIN. They all need to check this. So maybe it is just part of the requirements and it's not really part of design, you could argue. And that, people, when they start designing it, they're like, oh, well, this is how it has to work. Or this is what, it has to do. Or maybe this is part of the design where people have said this is our intelligent way to meet these requirements. So it would depend on the system. Yeah. Use case written form. This kind of goes into some more depth, but you know, it's mainly here just for illustrative purposes. Like, you could also give backgrounds on your use cases as well. If you were to give multiple ones, like, I don't really do this a lot, but I mean, again, because normally, like, if you gave this use case, you're going to give some kind of context around it. Like, how much money does the customer have? How much money does the ATM have? Are probably two obvious questions here, right? How much does the customer withdraw? Because there's nothing here about insufficient funds, right? So either you need to add that to part of the use case here to deal with insufficient funds, make a separate use case, or probably what you would do is make a separate use case, and this one is the use case for user tries to withdraw less than they have in their bank. You know, so you can give some background to a given use case, particularly written ones. You could also do this for diagrammatic ones as well. Yeah. There's some more reading on use cases as well. I was going to spend some time today doing a thing where we try and actually write out a set of requirements for UNSW's monorail. I just have this very fond memory of this article because back in 2012, the ARC put out an article that was like in July that was like UNSW is building a monorail from the bottom of campus to the top of campus, and everyone thought it was real. And then I think some actual news companies picked up on it. And it was very funny. So I just thought, well, wouldn't it be funny to actually sit down together and write out a list of requirements or use cases or user stories for what a monorail system would look like? Maybe we don't even need use cases. Maybe we could just have some requirements. Maybe we don't even need user stories. We probably do some user stories, but it's 2 minutes till the end of the lecture, so we're not going to do that today. We'll do that maybe in a later week if we have some spare time. It's not really critical. It's just a chance to actually put some of these things into action anyway. So, anywho, thank you all for today, and I guess I'll see you all tomorrow morning where we'll be talking about decorators, so a bit of Python tomorrow, and iteration 3, and if we have time, some Teamwork Thursday stuff. So please pause the video, leave some feedback, and thank you. Hope you all have a great day, and I hope you've, taking a chance to breathe after iteration 2. 1531 is a front-heavy course by design. It's designed to be harder at the start and then taper off around this time of term. So, don't get stressed that the worst is still to come. Because for many of you, the worst has just passed. Still lots to do, but, Anyway, have a great day. See you all tomorrow.